Hi, I'm Mr. Spohn, and today we're going to look at drawing Lewis dot structures for covalent bonds. In covalent bonds, and these are the rules for the structures we are going to draw. Atoms are going to share valence electrons to achieve an octet. They want to be like the noble gases. They're going to share electrons so their totals get up to 8. And there's going to be a circle test for the octet. Recall that hydrogen doesn't need an octet. Hydrogen wants to be like helium, so hydrogen only needs 2 electrons to be stable. When you're drawing these diagrams, carbon's always the central atom, never hydrogen. And then we talked about electronegativity. The least electronegative atom goes in the center. The valence electrons you start with must be the valence electrons your diagram has at the end. We can't invent electrons, or they can't disappear from our diagram. Whatever we're starting with, we got to end with. Conservation of mass energy. And sometimes when we're drawing things, this more symmetrical drawing is going to be correct. And we'll look at single bonds, double bonds, triple bonds, resonant structures, coordinate covalent bonds, and even formal charge. So we're going to start simple, but it's going to get a little complicated before it's all said and done. So let's look at HCl, or that's actually hydrochloric acid or hydrogen chloride. Hydrogen has 1 valence electron. It's the dot structures in column 1A. Chlorine has 7 valence electrons, and they would share their electrons in order to achieve a stable configuration. And if we were to draw the circle test, this is the circle test. You just draw a circle around the atom to see if it has 8 valence electrons, and chlorine does have 8. It passes the octet test. And if we wanted to test hydrogen, we could simply draw a circle around it, and if it has 2 electrons, which I won't do for the rest of the video, then hydrogen is stable. So this is going to be a stable diagram. And that's the Lewis diagram for HCl. What we do is we represent these shared electrons, this shared electron pair. It's going to be written as a dashed line. This bond right here represents 2 shared electrons between these. So that's how we write that. And that's what those lines mean when you see structural diagrams. Dash represents 2 electrons in a single bond. So let's look at water. Hydrogen has 1 valence electron, and we have 2 of them in water. Oxygen has 6. What happens when they come together? Boom, now oxygen has an octet. They're sharing their valence electrons. And the octet test is good. We could draw lines around each hydrogen. And each hydrogen has 2 valence electrons throughout the sharing, so that works. And we would draw this. Remember, each one of these lines represents 2 shared electrons. And with 2 bonds. In actuality, water would have a bent structure. We would draw it like this. But we didn't get to Vesper theory yet, so I would accept this for now. But water is not a linear molecule like this. Just an FYI. And recall that hydrogen is never the central atom, and we're looking for a bit of symmetry here, so we're not going to draw it as, O, H, H. We want a little more symmetry than that, and actually this wouldn't really work anyway for reasons we'll see later on. Diatomic chlorine gas. Chlorine has 7 valence electrons. There's 2 of them. What are they going to do? Well, they're going to come together. And we know chlorine is diatomic. It's sharing its valence electrons with itself. And that passes the octet test. The other chlorine atom passes the octet test. Chlorine is now going to be stable. And we would draw this bond like this. Remember, this represents 2 electrons, this bond. That's what this bond represents. So chlorine is stable. And what else can you tell me about other diatomic molecules? Well, pretty much all of the halogens in column 7A are considered diatomic. Fluorine has 7 valence electrons. It combines with itself. And that's why we call them diatomic. Iodine, bromine. And now let's look at NH3, which is ammonia. Nitrogen has 5 valence electrons. How many does it want? It wants 8. So we have 3 hydrogens, and each hydrogen has 3. Guess what's going to happen? Well, they're going to pair off. and share those valence electrons. And now nitrogen has its octet. It is happy. It is stable. And we would draw the final diagram like this. Remember, each one of these represents 2 electrons. And that is how we draw that. And remember, carbon has 4 valence electrons. And each fluorine has 7 valence electrons. And note the rule that I said you can't create or lose valence electrons. We have 32 valence electrons in this diagram to start. Each fluorine has 7 for 28. And carbon has 4. There's 32 to start. By the time we finish the structure, all we're doing is moving them together and fitting the electrons together so we achieve octets. We're not creating or losing electrons. We can't do that. So that test is being passed. And remember, we're looking for symmetry here. Carbon is always the central atom. And if that's not there, you go for the least electronegative if you don't have one with carbon. So what's going to happen? These are going to come together. And then we perform our octet test. Carbon passes. There's 8 electrons there. Fluorine passes. Each fluorine is going to pass. And we're going to get our carbon tetrafluoride flower, I guess, if you wanted to. Kind of looks like a flower. You draw a little stem. Terrible drawing. That was not an art major, but kind of looks like a flower. Students usually notice it's a pretty structure when you draw that out. But that's carbon tetrafluoride, and it passes the octet test. So for some simple molecules, we can just kind of look at valence electrons and kind of fit them together like Legos. But we're going to look at some more complicated ones, and we're going to look at a better way to actually draw these. And this would be how we would draw the structure for carbon tetrafluoride when all is said and done. And recall that each dashed line represents 2 electrons or a single bond, a chemical bond between carbon and fluorine, sharing those valence electrons. The next 3 bonds on the list, O2, CO2, and N2, they involve double and triple bonds, so we'll cover them in the next video. For now, you have an assignment. Using what we just did, and some of these are kind of the similar molecules, just different elements in the same column. Try to draw the dot structures for these 5. You should be able to get some of them. Remember the rules. Carbon's always a central atom. Look for symmetry. Try to get an octet. And hopefully you can now draw some very basic Lewis structures using dot diagrams or valence electrons. This is Mr. Zapone. I'm out.